folks. Welcome to
Vector calculus.
Alright folks, welcome to the next lecture in vector calculus. Today we're going to keep looking at 3D things, 3D surfaces, or if you're looking for a complex name, quadric surfaces. And let's see what surface we got today. But before we do that, what did we see yesterday? Yesterday we saw an M&M. The day before that we saw a nuclear power plant. Only God knows what we'll see today. So here's what we have. Z squared is equal to x squared over a squared plus y squared over b squared. Alright, so first thing I gotta do, draw the xyz axes. So here's my z, here's my y, here's my x, old story. So here's x-axis, here's y-axis, here's z-axis. Alright, now I'm gonna rewrite my equation right over here. So I got z squared is equal to x squared over a squared plus y squared over b squared. Alright, so let's start taking some slices and let's see what we get. First thing I'm going to do is take a slice of the xy plane. Well, if I want to take a slice of the xy plane, what do I got to do? Well, I'm going to set z to equal 0. So I'm going to set z to equal 0. And I'm going to assume that a and b are 1, just to keep things simple. Alright, so z is equal to 0. So pop out this term. So we're going to have 0 equals x squared plus y squared. What is that? That's just a point. That's the origin. That's the origin. That's a point. They're trying to trick you. Alright. Now, what if we just let z be a constant? Well, let z be a constant. Well, this would no longer be 0. It would just be some constant, right? So if you have x squared plus y squared equals some constant, well, then it's gonna be some circle, right? It's gonna be some circle. So you can imagine you got some circles on the xy plane as you change your cross section of the z. Okay, you have some kind of circles. Unfortunately, I'm not Picasso, so I can't. I'm gonna try to give a better rendition, but you know, the name of the game is you got circles. Okay, cool. Now let's look at our xz plane. To find out our cross section on the xz plane, what variable am I gonna fix? Well, I'm going to fix y to be 0, right? This is almost like finding the intercept of a two-dimensional line, except now we're doing it with three-dimensional surfaces. So instead of fixing points, now I'm fixing planes, okay? That's an important distinction to make. So if I fix y to be 0, take this term, pop it out, what do I have left? I have z squared is equal to x squared. Okay. Well, take the square root of both sides. What do I get? Well, I'm going to be left with the absolute value of z equals the absolute value of x. Well, do you remember how the absolute value graph looks like? Well, if you don't, good thing I'll remind you. The absolute value graph, remember, looks a lot like this. This is the graph of y equals the absolute value of x. And of course, if we have the absolute value of y equals the absolute value of x, we'll have something that looks like this. Okay, well now you just switch up the variables. Instead of x and y, you have x and z. So you kind of draw these x's. Can you imagine that? We have these x's. Okay, so that right there is our cross section on the xz plane. Not too bad. And finally, let's look at the yz plane. To look at the yz plane, what variable do I have to fix? Well, go ahead, fix the x variable. Set it to 0, and what do we get? Take this term, pop it out, and we have z squared equals y squared. Same story here. Same story here. We get the absolute value of z equals the absolute value of y. So we get yet another kind of x shape. Okay? If it looks complicated, don't worry, because all we really end up with here is a cone. It's just a cone. It looks complicated, but it's a cone. Because look at what you have. What do you have? What do you have? Well, here you got some circles, right? Do you see that? When you slice up a cone horizontally, perpendicular to the axis of rotation, you get circles, right? You also have some X-shaped I don't know what to call them, X-shaped conic sections, right? So you got two X shapes in two different directions, and you got circles in between. Well, that's just a cone. So what is this quadric surface? It's just a cone. Boom. That's it, cone. And that's it. That's a very nice quadric surface that we all like and we've all known for the past 12 years. Alright folks, that's it for this lecture. We'll check you out next time.
Embedded plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.